Today we're going to look at how we use the standard algorithm or the traditional process for division. Before you start taking notes, you might want to consider using graph paper as we work in division, because that graph paper will help you keep your place values lined up in your work. When we're setting up a division puzzle, it's very important to remember all the different parts of the division puzzle and what we're doing with each of those numbers in the process. Remember, we have a dividend and a divisor, and then the answer or the result of the division problem is the quotient. The dividend, written out as you see here, is always the first number in the problem. But when we set the division problem up for the standard algorithm for long division, we will take the dividend and place it underneath that division bar. And then we're going to take the divisor, the one that tells us how big our groups are going to be, and that goes on the outside of that division bar. And then the quotient will be the number that sits on top of that bar when we're finished with all the calculations. Now, the process of division is going to involve 3 steps that we're going to repeat as necessary until we either wind up at 0 when we subtract, or when we reach the point where we need to round to complete our work. So I'm going to do this example on the graph paper that you see on the page, so that you can see how this would be set up if you choose to use that paper. We're going to take that dividend, that first number, and write that 1 digit per square. We'll set up our division bar, and then our divisor is going out here. And then we're ready to begin. Now, where in addition, subtraction, and multiplication, we always start our work on the right or in the ones place if we're dealing with whole numbers. With division, we're going to start at the left, because we're really going to be trying to take the biggest groups that we can in our division at a time. So we're going to start by thinking about the 8 here in the hundreds place. We'll start over here. And the first thing we want to ask ourselves is how many times we can get 31 out of 8. So if you have $8, how many times can you buy a $31 shirt? Well, you and I both know that we couldn't do that. So we're going to then not just look at the 8, but we'll consider the 8 and the 7 right here. Okay? So we'll think about how many times we can get 31 out of 87. And if this is where our estimation skills come into play for us. Let's think about 31 as 30 for just a moment. And we know that 30 times 2 is going to be 60. 30 times 3 is 90. Well, that's more than we have here. So we know that we're only going to be able to get 31 out of 87 twice, and we're going to put that 2 over the last digit that we use. We talked about 87, so our 2 is going to go over that 7. So now we're going to do a little bit of multiplication. We're going to take that 2 times the 31, and that is 62. And notice how we're staying right under that 87 that we were considering in the first place. And we're going to subtract that. And if you think about this for a moment, that 2 is in the tens place, so that's really like thinking about 20 times 31, and that would give us 620 instead of 62. So you can understand why that 62 is scooted over under the hundreds and tens. We'll go ahead and do our subtraction. 87 minus 62. That's going to leave us with 25. And this is a good place to stop and check your thinking. If you wind up subtracting and getting a number that is smaller than your divisor, you know you're in good shape. You're not underestimating in your work. So at this point, we need to continue. So we are going to bring down that 8. So really all we're doing here is considering now the 258 instead of just the 250. So now we're going to repeat all of these steps. We're going to think about how many times we can get 31 out of 258. And with a little bit of estimating, we can think about 3 going into 25. That's going to be about 8 times. And then we're going to multiply again. So now we're going to repeat that process. 8 times 31 is going to be 8 and 24, 240. And now we're going to subtract again. And we wind up with 10. Now we have no more digits in the dividend to work with. And we, at this point, if we want to go into decimals, we can, but we can also stop here and treat that 10 as a leftover, as a remainder. So in long division, in the division algorithm, this is showing that we could get 31 out of 878 28 times, and we would have 10 parts or 10 pieces left over. I want to stop for just a moment and make some connections here because we've worked a lot with fractions in the last unit, and we talked about fractions being division problems, and that's still true, so I want you to see it from the division side of this. The idea of 878 divided by 31, remember that's really this fraction, 878 over a denominator of 31. And when we were working in the fractions unit, when we would come across a fraction like this, we called it improper because the numerator is larger than the denominator. So we would do some division to find out how many whole groups of 31 we could get out of 878. Well, that's the same division process we're doing in long division. So we would find out that we could get 28 whole groups, and that we would have 10 left over. There's that remainder that we just discovered in the division problem. And we always put that over the same denominator because the sizes of the pieces didn't change. So this is really one and the same. The idea of 28 remainder 10 is exactly what we've been working with in fractions. It's another way of representing that mixed number. All right, let's go back and do some more practice. And again, I suggest that you do this on graph paper so that you can really make sure those place values are lined up. So we're going to take the dividend here of 318 divided by 16, starting at the left and working our way over. So the first question would be how many times can you get 16 out of 3? And we can't do that. If we only have $3, we can't spend 16. So we're going to move over and take one more place value and consider 31 now. So the question would be, how many times can you get 16 out of 31? Well, 16 times 2 is 32, so we can't quite get 2 whole groups out. Just get my purple marker back. So we're going to have to just accept 1 right here. So we did our division. We're now going to multiply 1 times 16, which gives us 16. Notice the alignment, that 6 is under that 1 in the tens place. We'll subtract 31 minus 16, and that's going to leave us with 15. We'll check here. The difference is smaller than our divisor, so we're in good shape. We can continue. We're going to bring that 8 down so we can think about how many times 16 would go into 158. And 16 times 10 is 160, so we're really close to that 160, but we wouldn't quite get 10 groups of 16 out, so we'll stick with 9. 9 times 16 is going to be 144. And when you subtract that, you're going to have 14 left over. So with the long division algorithm, we would have 19 remainder of 14. And again, just to build that connection, that would be written as 19 and 14 sixteenths when we think about fractions. And we could simplify that to 19 and 7/8. Okay, so I really want you to understand what that remainder is representing, that it really does have a value in our mathematics. All right, one more example for this lesson. We're going to take 2,480, divide that by 31. Okay, and we'll start at the left, thinking about how many times we could get 31 out of 2, and that doesn't work for us, so we'll take another digit and think about 24. Well, that's not going to work for us either because 31 is larger than 24. So now we have to think about 3 digits. How many times could we get 31 out of 248? So again, we're going to estimate. Let's think about 31 as 30 and 248 as 240. Okay, so we can think then about how many times would 3 go into 24. And that would be 8 times. And we're going to put that 8 over the last digit we were considering. We'll now multiply and do 8 times 1. Then we'll do the 8 times 3. We're going to subtract now. That same process keeps happening over and over again. 248 minus 248 is 0. But you'll notice we still have a 0 in the ones place of our dividend. We can't just ignore that, so we have to think about what would happen here. If we brought this down and continued the division process, we'd see that we had 0 divided by 31, which is 0. Okay? It's really important. You can't leave any whole number place values without a digit. So if you do your division and you subtract and get 0 like we did in this particular example, then you know that the remaining whole number digits are going to be 0. Alright, please make sure you write down any questions that you may have and bring them back so that we can conference about your concerns.